monomials are interesting because monomials are a real number, a variable, or a product of a real number and a variable. An example of that would be our constants that we have. So let's do our 9. A variable is an x. A product of a real number and a variable is like a 3x. So anything that's a real number, which means that it doesn't have an imaginary component, and we'll talk about that probably at the end of the year, is going to be a monomial. And when you think about this, mono means one, nomial means name. So this is like a Latin term that they made up, and it just means that one name or one term. So let's talk a little bit more about these monomials. The degree of a monomial is the sum of the exponents on the variables. A non-zero constant has a degree of 0. So if you have any constant that is not a 0, its degree is 0. And 0 has no degree. So the reason that a constant has a degree 0 is because it doesn't ever change. 0 has no degree because it's just a really weird one, and it kind of breaks all of our rules. So we'll just have to remember that one. Let's go through some examples of monomials. We have our traditional 3x. Now if you look here, the power of that is to the first power, which means that our degree is going to be, here I'm going to call it d, is equal to 1. Now let's do another one over here. We're going to do some wacky power. Let's do 7x to the 30th. Well, our degree is still going to be our power. And so right here you have the x, the variable, that's been raised to the power of 30. You also notice that because we have our number here, our constant, times into that, its degree is 0, so you have 30 plus 0 is equal to 30. So its degree is 30. Let's look at something else that's a little bit weird. Let's do x squared y to the 4th. Well, this one is weird because you're thinking, oh my gosh, there's two variables, but it's okay because they're multiplied together. And so what we're going to do is we're going to say, what's the degree of the x? And the degree of the x is 2. What's the degree of the y? Well, the degree of the y is 4. So 2 plus 4 is 6. The degree of that monomial is 6. And we'll use that a little bit later, so just hold on to that and we'll go with it. Actually, we're going to use it right now. I want you to do a quick check, and I want you to take a moment and pause the video and find the degree of each of the monomials. The first examples have some highlighted hints. So, like on that first one, 5x, you don't see anything above the x, which means that it's raised to the first power. I'll write that in there for you. So you know that the degree is equal to 1. And I'm going to let you do all the rest of these. And remember that the stars are the ones that I really want you to work on. Now we're going to go through and combine like terms. So combining in like terms means that you can add and subtract monomials by adding or subtracting the things that they have in common, or the like terms. Basically, you're just making them look really pretty. Now we're going to go over some examples for you over here. Let's go back to our 3x, but this time we're going to add a 7x. So since we're still talking about x's, and remember that before we called x's to represent the number of apples, if we have 3 apples and we're adding 7 apples, that works. We can have 10x or 10 apples. Now the problem here as well, you have to remember that they have to be like terms. So 3x plus 7y is not going to equal, you put a big X here, make it red so that you know, does not equal 3x 7y. Absolutely not. Because you're trying to add them, and since apples and oranges aren't the same, you can't add them and say, oh yeah, now I have this. You still have to go through the fact of saying that there are 3 apples and 7 oranges, or 3x and 7y. And let's do a really fun one. Let's do like 4x squared plus 8x squared. So that one is going to equal, so we're going to say, okay, so our x squareds are going to stay because they're a like term. You're not going to add the exponents. That's just like we're saying that we have a square of apples. So like a box that, or a square that is full of apples. And we have 4 of those squares and 8 of those squares. So what we're going to do is we're going to say that we have 12 of them. So we're adding the 4 and the 8 to get 12. Now what if we had 4x squared y squared plus 8x squared y squared? Well, that's going to end up being the same thing to a point. Our x squareds are going to stay the same. Our y squareds are going to stay the same, but our 4 and our 8 are going to add together, and that's going to be 12. That's time for another quick check. This time, what I'm going to have you do is I'm going to have you combine the following monomials. The first 2 have some highlighted hints. If you can't combine them, I want you to say why. So this b that I have highlighted is kind of mean, but it's like that last example that we just did. We have 6x cubed y squared plus 3x cubed y squared. Since they both have an x cubed and a y squared, we can add them together because they're like terms. 6 and 3 is 9, and that's going to be 9x cubed y squared. And I'll give you a second to pause and look at these. Now we're going to classify our polynomials. So basically we're going to go through and name them. We're not going to name them fun names like John or Jacob or, I don't know, Jingleheimer Schmidt. Instead, we're going to name them different things. So a polynomial is either a monomial or some monomials added together. Now remember, when we're talking about monomials, we notice the fact that it has mono, meaning one, nomial, meaning name. Here we have poly, meaning many, nomial, meaning names. So we have many terms added together. Standard form is just when the terms are ordered from largest to smallest. So if you have x to the 4th plus x cubed plus x squared plus x plus, I don't know, constant of 7, that means that they're ordered from largest to smallest, because you have to remember here that our x all alone has a power of 1. Our constant has a power of 0, so we go from the greatest power of 4 all the way down to 0. So we have 4, 3, 2, 1, 0. And that's our standard form. A polynomial can have constants, variables, and exponents. So if you look up here in this polynomial that we have right here, we have a constant. Here, I'll highlight it in red for you. We have variables, so like this, and we also have our exponents. But they can't have negative exponents or number in the denominators, because that'll just kind of change up some stuff. So this should actually be the variable. So you can't have a negative exponent, or you can't have the variable in the denominator, because it turns it into a different thing. And we'll go over that, I don't know if this year, but it might be next year, and if not next year, it'll definitely be in Math 3. So let's classify some polynomials. The degree of the polynomial for certain variables is the same as the greater degree of the monomial with that variable. That sounds like a lot, and that's okay. We're going to give you an example here, and this one already magically showed up for me. X squared plus 9x plus 20. So the degree of this polynomial, this entire thing, our degree, is going to equal the greatest degree in that variable. So we're going to call degree of x. So our degree in x is going to be the greatest power. Well, the greatest power is this squared right over here. So we're going to call it degree in x is 2. What about this one? This one looks really scary, but it's not that bad. Let's break it up again. We're going to call degree in x and degree in y. You don't actually have to write it that way. That's just the easiest way for me. So our degree in x, well, let's look and see what our greatest power is in that variable. Our greatest power in x is 2. So the degree in x is 2. But what about y? Well, our y has a power of 3, which means that its degree, and there's no other, like there's this other y, but it has a 1. And so our degree in y is equal to 3. Hopefully that makes sense. If not, we'll talk about it a little bit more in class. And we're going to do some examples here. So we already did those two. Let's go and do 5x fourth plus 7x. So we're going to look at this. We're going to say, okay, so our highest degree, and remember that this one's in x, our highest degree is our greatest power is to the fourth, so our degree is to the fourth. Let's do a really mean one. We're going to do 5x plus 7x cubed plus 11x squared plus 4x to the fifth. Now this one isn't really nice. It's not in standard form because it doesn't go from 5 to 0 times x to the fourth times 3 to, or x to the third, to x squared to x. But that's okay because we only care about what the greatest number is. And so since we don't want to do the work of rearranging it, we can just go through and say, okay, so that one's x to the first, that one's x to the third, so right now we're at degree 3. X squared, 2 is still smaller than 3, so that's fine. X to the fifth, 5 is bigger than 3, so that means that our degree in that is going to be 5. So this polynomial right here has a degree in x that is 5. And we can name our polynomials. And some of these have special names. For example, a monomial is a polynomial with only one term. Now we're going to have this beautiful little graph here that basically says that not all polynomials are monomials, but every monomial is a polynomial. What it means is that 3x is a polynomial, and so this is polynomial and monomial. However, 3x plus 7 is only a polynomial. Cool? And there's some interesting things here, and I'm sorry that this cut off a little bit. It looks a little bit better on the notes, and I'll give you those ones better. But here's a nice little table. So up here we have the example, and on that side is going to be some examples for us. Our degree, the name from our degree, and then we're going to have the number of terms, and our special name from the number of terms. So for this one, we have 6. Well, we know that 6 is a constant, which we see right here. But 6 have a degree of 0. So since it has a degree of 0, it's constant. And since it only has one term, it is a monomial. This one right here, 5x plus 9, has a degree of 1 because it's on the 5x. X has a power of 1, which means that it's linear. And since it has 2 terms, because you have 1 term, 2 terms, it's going to be binomial. This one has a degree of 2 because you're 4x to the squared. That's your highest degree. That's your highest power, which gives us the name of quadratic. Now, it has 3 terms, which makes it, so you have 1 term, 2 terms, 3 terms, and makes it a trinomial. Here we have 2x cubed. Its degree is its degree is 3, so it's a cubic function because we're talking about, if you remember back with our example with like terms, you have x times x times x, and it makes a cube, and so that's where we got that name. But since it only has 1 term, it is going to go back to this monomial thing. Here we have 8x to the fourth, so our fourth is our greatest power here, which means that its degree is 4. And we get lazy after this. We just call it to the 4th degree. Anything after this, you just use its name. So like to the 4th degree, to the 5th degree, to the 907th degree, That's just what you're going to do. And since it has the 3 terms, we go back to our trinomial. Now I'm going to have you do a quick check right now, and I'm going to have you pause the video, and we're going to classify as soon as I'm done giving the instructions, and that is to classify the following polynomials. What is their degree by name? So we're going by their name by degree, and their name by number of terms. And the first 2 of these has some highlights in here for you. So we have 5x squared plus 7x. You'll have to find the degree, and then you'll have to figure out what its name is from the degree and what its name is by number of terms. And I'll want you to do that with all of them. And you notice that B and C are the ones that are starred, with B having the really weird looking letter, and that's just called omega. And I'll have you pause, and we'll talk a little bit more about this in class.